Hello and welcome to another ID Math Speedrun with me, Vince. So we're going to be finishing off Unit 3.1, and yeah, the last thing we need to know is quadratic inequalities. So let's jump right in. So a quadratic inequality is when ax squared plus bx plus c is like greater than 0 or less than 0. It's just not equal to 0. And we need to know how to solve this. Yeah. So there are really two ways of solving it. The first one is to factorize it. For example, we have can be x minus I times x minus j is greater than 0. And we know this is only true if both of these are positive or both of these are negative. And so that's one way to solve the inequality. Now the other way to solve the inequality is if we can't factorize it, this is the method we use, we would have to get the roots of the equation and then test for numbers between them to see whether it's positive or negative. So we know that a quadratic will only go either completely down or completely up. It's not like a cubic or any harder equations yet. And so if we have these two real roots, by testing if the middle is lower or higher than the x-axis, and of course, yeah, if it's lower or higher than the x-axis, then we can find whether the for what values is the quadratic inequality true. So the best way to show this is to jump into some questions, so that's what we're going to do right now. And I'll be doing the odd ones. Why not? So first we have x squared plus 6x plus 8 is less than 0. And so for this, we can just simply factorize it and find out what values are. So we have x plus 2 times x plus 4 is less than 0. And well, we know that for this to be less than 0, either one of these has to be negative. And since x plus 4 is greater, then it will always be greater than x plus 2. We need to find the values. Well, actually, no, the values are pretty simple. It's the values between it's the values between sorry, having a brain block. Because the roots will be here. So it's the values for which x plus 4 is positive, but x plus 2 is still negative. So the values for which x plus 4 is positive is when x is greater than negative 4. The values for which x plus 2 is still negative is when x is less than negative 2. And so to satisfy both of these, well, x simply has to be between negative 4 and negative 2. And that is all. So if we want to verify this graphically, then the graph of this equation looks something like this. Let's draw it out. Roughly like this, with this being negative 4 and this being negative 2. And so we can see for the values between negative 4 and negative 2, they are clearly negative or less than 0. So yeah, that's it. So for the next equation, we have x squared minus 13x minus 30 is greater or equal to 0. Okay. No, actually no, we can easily factorize this. This would just be x minus 15 times x plus 2 is greater or equal to 0. So we need to find the values for which, well, we know x plus 2 will always be greater than x minus 15. So we need to find the values for which x plus 2, for which x minus 15 is greater than 0 or x plus 2 is less than 0. Since if x minus 15 is greater than 0, then it follows, of course, that x plus 2 would be greater than 0. And since both values are positive, they're multiply. When we multiply them together, the result will be positive as well, or greater than 0. However, if x plus 2 is less than 0, it also follows that x minus 15 would be less than 0. And so, or less than or equal to 0, I should say. and therefore both values are negative, and negative times negative will be positive. So our two values would be x is greater or equal to 15, or x is less than or equal to negative 2. And yeah, those would be the two values. Pretty simple. So finally, we have the equation 8 is less than 5x squared minus 6x. So first we want to bring 8 over to the other side. So we have 5x squared minus 6x minus 8 is greater than 0. And I guess we could factorize this, but I do want to briefly cover the other method of actually solving this, and that would be using the quadratic equation. So we know that the roots would be 6 plus or minus the square root of 36 plus 4 times 8 times 5, since this is negative 8, which would be 160, over 2 times 5 is 10. And so this is 6 plus or minus the square root of 196, which is 14, over 10. So this would be either 2, x equals 2, or 6 minus 14 is x is equal to negative 8 over 10, negative 4/5, I believe. So now we want to do a sign test. I mean, technically we could just look at the equation, but if we want to do a sign test, well, let's pick a value in between these ones, say 0, and let's test whether x is positive or negative at that point. So we have 5x squared minus 6x minus 8. So since x is 0, it would simply be y is equal to negative 8, and so this is negative for this value. So the curve will look like this, where there's a negative between the two roots. And so finally, well, it's asking us for what values is this greater than 0. Well, so since the in between these roots it would be negative, we must simply get the values outside these roots. So this would be x is greater than 2, or x is less than negative 4/5, and that will be all. So yeah, that was a pretty fast speed run, and I hope to see you in the next speed run where it gets harder. See you.